Hello boys and girls, Mr. Giomini. Wanted to come to you with a little bit of a review for your upcoming Topic 3 Numeric and Algebraic Expressions post-test. This is a 100-point test. What I try to do is find some pictures for you to kind of just jar your memory, maybe create a little image mentally in your head of some of the things that we've done over the course of this topic. Quite a few things. The thing is, everything's a basis though, boys and girls. The basis is that fundamental fluency you have in your computations. Adding, subtracting, multiplying, and dividing. Whether it's with PEMDAS, whether it's calculating GCF or LCM, powers and exponents, exponential notation, or evaluating algebraic expressions. All these things are grounded in our ability to add, subtract, multiply, and divide. Now, just a little reminder, what are the best ways to use videos such as these? We can be a passive viewer and watch it like we would watch a TV show. And typically watch a TV show, we just sit there and let the show entertain us, and then once the 30-minute show is over, we go on to something else. This is supposed to be, and hopefully it is, an educational video, one that you learn something from. What you can do is always pause this video. Once the question comes up, pause the video, attempt to solve it, then resume the video. If you start to see that your answer and my answer are somehow having a disconnect, not having any parallels with each other, we should then pause the video, or you should, I can for you. Pause the video and then look at your work, look at mine, see where they differ, erase your work, or maybe I made a mistake, we know that happens every day. But erase your work and then see if you can erase it, take what I have, and then continue to work from what I had, and then see if you get the right answer, and then resume the video, and do that in that fashion for every single question. I think you get a lot more out of the video if you're more active in it rather than just kind of sitting passively back and watching it. So let's take a look at our first question here. It says, evaluate the expression below. Enter your answer in the box. Well, I see here I have open parenthesis 8 1/10 plus 7 4/10 close parentheses minus 25 divided by 2.5. Well, I had that picture earlier on the thing, but I can't go back to that. So let's go PEMDAS. And sometimes it is beneficial for us to write this little acronym out. And when I do this, I kind of have to remember that multiplication and division, the same with addition and subtraction, whoever comes first from left to right. We get in the habit of reading PEMDAS and seeing the M first and saying, oh, I have to multiply first. Well, if there's multiplication and division in the expression, we look at it like we read a book. We go from left to right. Well, in this situation here, I have parentheses. Let's tackle those first. I have 8 1/10 plus 7 4/10. 1/10 plus 4/10 gives me 5/10. The decimal point, because when we add, we line up decimal points. Nothing to carry over, nothing to regroup, no extra 10 or something like that. We have 8 plus 7 gives us 15. I am now done with the parentheses. Those parentheses are no longer in existence. I have simplified everything inside those parentheses. That's gone. I can do the minus 25 divided by 2.5. Now I have subtraction and division left. I'm going to cross out the P, no parentheses, cross out the X, E for exponents, no exponents in there. Now we do multiplication, division, whatever occurs from left to right. Well, all we have in this is division. This is a nice test for us because now we got to go back to topic 1 and recall that 25 becoming my dividend divided by 2.5. But we should recall that we cannot have decimal divisors. It's much easier for us to work with whole number divisors. We move the decimal over once, so now the new divisor becomes 25. We move the decimal over once here. Now this new dividend becomes 250. Okay, now we have 250 divided by 25. Well, obviously, if we just multiplied this by 10, it would give us that 0. So 25 goes into 250 10 times. So I've just simplified this part of the numeric expression to be 10. I'm going to erase this to get it out of my way. Now I have 15.5 minus 10. This is something similar to I have $15.50. I buy something for $10. The change that comes back is $5.50 or 5 5/10. And again, I'm not necessarily lining these up because I need to start to become more fluent and understand I don't need to always line stuff up. I should start to see this in my head a little bit more. This shows that I really truly have an understanding of mathematics where I can do some of these simple calculations in my head without having to write it out. But just for those who need a little bit more visual, I put a decimal here after the 10 because all whole numbers, in essence, have a decimal to the right of it with endless number of zeros. We go 5 minus 0 is 5. 5 minus 0 is 5. 1's out. So the correct answer here would be 5 and 5/10. Let's take a look at question 2. Muffins are sold in packages of 18. Alright, so if I want to think about this, I have a package here of muffins. I go to GetGo. There's 18 in it. And usually they come in on a shelf, and all these packages have 18 muffins in them. Alright, so if one person comes and buys them, well, one's gone, but they're all in packages of 18. Select the expression that can represent the total number of muffins in P packages of muffins. So we know the coefficient here, and I'm using the word coefficient because that's how many are in each one, 18. Now, if I were to buy 2 packages, I would combine these, I'd have 36 muffins. If I were to buy 3 packages, I would have 54 muffins. If I were to buy 4, I would have 72. I'm repeatedly adding the number 18, but an easier way to do repeat addition is to multiply. So I know that I'm always going to have 18. It depends on how many packages I buy. So it's 18p, or we could do 18 times p. Now there's a couple different ways to show this, or 18 open parenthesis p close parenthesis, because I'm consistently adding 18. We don't know how many I buy, depending on how much money I have, so we go 18 times p. Now it says select the expressions. Keyword here is expressions is plural. Let me highlight that looked a little sloppy. I'm buying, it says select the expressions. It's plural, meaning there's more than one right answer. We have 18 plus p. Well, if I bought one package, if I put a 1 in here, is 18 plus 1 18? No, it's 19. It doesn't work. 18 times p. This would be correct. Now, I don't like that they gave this answer because we should get away from using this time sign like this because we could get it confused with a variable. But this is the correct one. 18 minus p. Again, let's just say I bought one package. 18 minus 1 gives me 17. Well, I wouldn't have 17 muffins. 18 divided by p? No. If I bought 2 packages, 18 divided by 2 is 9. How could I have, if I bought 2 packages, I could only have 9 muffins. And then finally 18p, where I have 18 is the coefficient, p is the variable. Again, boys and girls, the way I'm talking out loud with these problems, you can do the same thing in your head during the assessment. Think out loud in your head. It really helps, I know me personally, to work through some of these problems. And again, I go back and said select the expressions. I have 2 answers. Makes sense. If I had 1, I'd start to say, wait a minute. It says expressions. I should have more than 1 answer. Let's move on. Select each expression that has a value of 36 when x equals 12. Alright, now, we know that x equals 12. We are looking for it when it has a value of 36. I'm going to have to do some calculations here. And again, the more fluid I am, the easier this becomes. So I have 432 divided by x, but now we know x is equal to 12. What I'm going to do is simply substitute in. So it becomes 4,003, I think I said 432. 4,320 divided by, and x is equal to 12. We want the answer to be 36. Well, I already know this is not right because I'm going to get an answer in the hundreds. Reason being, 12 goes into 43 3 times. I still have 2 place values. I'm not even going to do the rest of this math. I'm done. Let's move on to the next one. We are substituting in the x, or 12 for the x. This now looks like 288 divided by 12. We have a little order of operation here. Plus, and I can write it like this, 16. Well, 12 goes into 28. Let's see. 2 times, and that gives us 24. We subtract that, gives me 48. I believe 12 goes into 48. Is that 4 times? 12 divided by 4, 4 times, correct? That gives me 24. 24 plus 36, I believe, gives me 40. Is that right? I need an answer of what? 36. That is too big. Moving on. I now substitute in the 12 for x. Ooh, this one's a little tougher. We have an exponent. 12 to the second power divided by 18 plus 28. Now notice, open parenthesis, close parenthesis. We have 12 times 12. 12 to the second power. Remember, the exponent tells us how many times you use the base as a factor. It says, hey, use that base as a factor twice. 12 times 2 is 144. 144 divided by 18 plus 28. We have 144 divided by 18. That's going to give me 8. This gives me 8. So now I have 8 plus 28. 8 plus 28 gives me 36. I have found my first winner. Let's look at the next one. Substitute in that value for x. Let me erase some of my work here. 1,752 divided by 12 minus 110. 1,752 divided by 12. Put the minus 110 over here. 12 goes into 17 one time. Now, before I stopped here, because I knew that I couldn't have an answer of 100, but I have to recall I am subtracting over here. I'm going to continue doing this math. Put 12 here. That gives me a 5. Annex down that 5. 12 goes into 55 4 times. We figured that out earlier to be 48, just using that previous math I did. I believe that this gives me, let's see here, 48 is 2 away from 50. 50 is 5 away from 55. 2 plus 5 gives me 7. Annex down the 2. This gives me 6, I believe, because 6 times 2 is 12. Gives me, okay, 72. But now I need to recall I have to subtract 72 from this. Whoa. Subtract 72 from this. So 110. Oh, wait, no, I'm sorry. Am I subtracting 72 from? I need to subtract 146. There we go. See? Make mistakes. But it's good to see me make mistakes because notice how I caught myself. I said, wait a minute, 72 is not the answer, it's 146. Now I go 146 minus 110. 6 and 3. Hey, we found another one that works. Excellent. And I'm feeling a bit more comfortable because in the directions it says select each expression, which to me implies there's more than one right answer. Let's go back and substitute that 12 in. Now we have 12 divided by 12 plus 36. 12 divided by 12 is 1. 1 plus 36 gives me an answer of 37. I need an answer of 36. All right, now that problem, I don't know because I wasn't looking at the timer. Problem took me a little bit of time. I'm okay with that. I need to be able to persevere, get through these problems. But again, I'm pretty fluent with my math facts, so I can move through it more efficiently. All right, so on to question 4. It says the same digits are used for the expression 3 to the second and 2 to the third. Select the symbol that correctly compares the expressions. Okay, I want to do is go to this. I'm actually going to go to the actual online assessment, and I want to show you because I can't do it in a picture format. This is going to become an inequality, so we're looking, are they equal, or they only give us 2 choices, equal to or greater than. Equal to or greater than. Going back now to my work, let's evaluate for 3 to the second power. Let's recall that that means what is 3 times 3? 2 to the third power. Let's recall that just means what is 2 times 2 times 2? 3 times 3 is 9. 2 times 2 is 4, times 2 is 8. You know what? 9 is always greater than 8. So this would be, I would choose the greater than symbol. Right? They're trying to trick you here, boys and girls. They're trying to get you to think, get you to see, oh, all I do is multiply the base times the exponent, and then that would go to give you 6. Don't fall for that trick. You are too smart for that. We've worked too hard for you to fall into that trap. So do me a favor, don't do that. All right? That's a common mistake I see from 6th graders. Just want to multiply base times exponent. We know that the exponent tells us how many times to multiply the base by itself, or use the base as a factor. Choose yes or no if the expressions are equivalent. This would be a little tough one. Again, requires some work. We have 8b plus 16 and 2 open parentheses 4b plus 8. Now, let's take a look. I'm going to look at the one that has the 2 on the outside. I did recommend this conskill to you. We can use what we call, and we've talked about this, the distributive property. Let's just go ahead and share this 2 with everything inside. Now, when I share it, I'm using the operation of multiplication. Now, we have the 8b plus 16. We'll leave it like that. 2 times 4 is 8, and it's 8b. Plus 2 times 8 is 16. Hey, that equals each other. Now, if I look back at this one, I look at the 8 and the 16. I could do a couple things here. It looks like they just factored out a 2. So they said they didn't find the greatest common factor. They just found a common factor. They said, hey, I'm going to factor out 2. When you do it that way, we divide both terms by 2. 8 divided by 2 is 4. We can't divide a variable by a number, so it just becomes 4b plus 16 divided by 2 is 8. So those are yes. That would be a yes here. Next one. I'm going to give myself some room to work. I would spend some time on these, boys and girls. These are the ones that I've seen in the past where kids struggle a little bit. Really hit that conskill up if you haven't done it already. Take a look at the next one. It says 2 times, open parentheses, 6 times m plus 2 close parentheses. And hey, is 8m plus 4. Could do the same thing I did for the previous one. Let's use the distributive property. Now remember, I must multiply by both terms inside the parentheses, not just the first one. We go 2 times 6 is 12, and the m comes with us, plus 2 times 2 is 4. Well, the 4 works, but the 8m and the 12m are not the same. This would be a no. We'll put a no there. Okay, let's take a look at the next one. Let's take a look at the next one. We have 4 times, open parentheses, 4a plus 3 and 16 plus 12a. I'm going to do this way a different one. I see that the 4 is on the outside. So that tells me they factored out a 4. They found a common factor for this. So I'm going to do that. I'm going to do the reverse now. I'm going to say, hey, the greatest common factor of 16 or 12, or just a common factor of 16, 12 is 4. I'd agree with that. I'm going to pull a 4 out. Now, open parenthesis. All that means is I divide each of these terms by a 4. 16 divided by 4 is 4. Good. Plus 12 divided by 4 is 3, but we cannot forget this variable a. Now let's see, are these two equal? Wow, the numbers sure look the same, but notice in this problem the 4 is the coefficient. In this problem, the 3 is the coefficient. That's not the same. So this 2 would be a no. This 2 would be a no. Yes, the numbers are the same. The numbers on the outside are the same, but you have to pay attention to details. The variable a is with the coefficient 4. The variable a here is with the coefficient 3. That makes them not equal. Let's take a look at the last one. Again, I'm going to reiterate. I'm going to continue to think out loud in my head as I solve these. We have 9x is the first term, minus 6 is the second term. Remember, terms are separate by addition or subtraction signs. We have 3 times 3x minus 2. I'm going to use a similar thing that I did last one. Here I see that they used a factor of 3. Well, 9 and 6 do have a common factor of 3, so I'm going to factor out a 3. All that means now is I divide both of these by 3. 9 divided by 3 is 3. The variable comes with the coefficient. Minus 6 divided by 3 is 2. 3 and 3, check, check. 3 and 3, check, check. Variable x, check, check. Subtraction sign, check, check. 2, 2, check. I have a right answer here, so this is a yes. All right, hope this helps out. This, boys and girls, is really a one I've seen the past couple years kids have struggled with. So use this to your advantage to polish this up a little bit. All right, let's go on to question 6. Choose yes or no to tell whether 6 is the greatest common factor of the pair of numbers. Now, is to tell whether 6 is the GCF of these numbers. Not just a factor, but the greatest common factor. Okay, I'm going to use the latter method for these. 12, 18. One factor that 12 and 18 both have in common is a 2. 12 divided by 2 is 6. 18 divided by 2 is 9. Now, do 6 and 9 have a common factor? Yeah, they do. It is 3. Put the 3 out. 6 divided by 3 is 2. 9 divided by 3 is 3. Do 2 and 3 have any common factors? Yes, 1, but they're both prime numbers. All numbers have a common factor of 1. We stop. We're doing GCF. Look at the numbers to the left, and we multiply. 3 times 2 is 6. Yes, 6 is the greatest common factor of 12 and 18. Let's look at 12 and 16. Let's go to 12 and 16 now. Use my ladder method. 12, 16. Upside down division sign. What is a common factor that 12 and 16 both have? They're both even. I'm going to go with 2. 12 divided by 2 is 6. 16 divided by 2 is 8. 8 and 6 are both even numbers. They have to have a common factor of 2. 6 divided by 2 is 3. 8 divided by 2 is 4. Uh-oh. That doesn't look like an ugly 3. Sorry about that. There we are. Okay, 3's prime, 4's not. They have no common factors because 3 is not a factor of 4. I am done. GCF, look at the numbers to the left. 2 times 2 is 4. We want a GCF of 6. This would be a no. I'm going to go here real quick. 6. Let's look at 18 and 27. I'm not even going to do the ladder method. Is 6 a factor of 18? Yes. Is 6 a factor of 27? No. The only factors of 27 are 1 and 27, 3 and 9. I'm not going to bother with the math. This is a no already. Again, the more I work with multiplication facts, the more I can start to pick up these things quicker and just not even have to worry about necessarily writing out the ladder. I have to begin to develop that fluency, that comfort level with this math. I go 30 and 54. Now, I'm going to do this one a little differently. The previous ones I've just used the even number. Now, I'm looking at this. Again, I could go 2, but you know what? I'm feeling confident. I know a larger factor than 2. 6. 6 is a factor of both 30 and 54. 30 divided by 6 is 5. 54 divided by 6 is 9. 9 and 5 are both prime, or excuse me, wait a minute. 5 is a prime number. 9 is not. 9's factors are 1 and 9 and 3. Because 5 is not a factor of 9, these numbers have no greatest common factor or any common factor besides 1. So there's my GCF to the left. It's 6. This is a yes. I'm done. Hope that helped you out a little bit. Expect to see that too. Moving on. Oh boy, we got a big word problem. The application pieces, which I've always talked with kids, even talk with parents, like the application piece, Mr. Meany, the big word problems. These are most cumbersome for my child, and I understand. So let's take a look here. Miss Thompson wants to buy centerpieces to use at a party. It will cost $49 to have the centerpieces delivered, plus 89 cents per centerpiece. So just to have them delivered, it's going to cost $49. But then, plus 89 cents per centerpiece. Now, let's think about this. I'm having a party at my house. I want to have a fancy party for my one friend that I have. It will cost $49 to have the centerpiece delivered. Plus, there's the plus sign. So if I have one centerpiece delivered to my house, it's going to cost me $49 for that one centerpiece. Plus 89 cents per centerpiece. So I got to pay an additional 89 cents or 89 hundredths per each centerpiece. So if I rent one, it's the $49 to have it delivered plus the 89 cents because I only rented one centerpiece. If I get 2 sent, I have to have $49 for delivery plus whatever 89 cents is times 2 because I'm continually adding 89 cents. So my algebraic expression looks something like this. $49 because that's always going to be my constant. No matter how many I have delivered, it's going to cost me $49 plus however many I rent. I'm going to put X here for right now because they haven't given me a variable to use. Now it says, let C equal the number, oh, there it goes. Let C equal the number of centerpieces that Mrs. Thompson purchases. Choose the expression. Hey, choose the expression. That means there's only one that shows the amount of money she'll pay altogether for each centerpiece. Now, we have 49 times C. I am not paying $49 for each centerpiece. This can't be right. 89 cents plus C plus 49. Well, if I rent one centerpiece, that becomes 89 cents plus $1, which is $1.89 plus 49. So it's something like whatever, $50.89. That doesn't quite make sense because if I get two, it doesn't add up right. I'm paying 89 cents per. Per thinks of multiplication. That per, think of multiplication. This here is the distributed property, saying you're going to multiply the number of centerpieces you rent times the cost per one, and then multiply that by the delivery costs and add those. That's a lot of money. Here we are. This looks identical to the one I wrote. Here's our correct expression. Delivery charge plus how much you're paying per centerpiece to rent. All right, so we have that. Let me get a little bit of erase here because I roll over this. There's my winner. Now, that's part A. Let's go to part B. Evaluate. Now that means, hey, we're going to give you a value for the number of centerpieces you rent. Evaluate the expression to find out how much Mrs. Thompson will pay if she orders 400 centerpieces. Now, boys and girls, we have selected the correct expression. Let's substitute in, like I think we did for question 3. Let's substitute back in now. 400 for the C. So this expression is written now as 49. What was an algebraic expression becomes a numeric one now because we have the value for C. 89 hundredths, or 89 cents, times 400. Notice how I wrote it. I used open parenthesis, 400 close parenthesis. I don't want to use the time symbol. That gets me confused with variables. You need to do a little math here because multiplication becomes before addition. And then you go to the side here. Watch how I multiply this 89 hundredths times 400. I think we'd all agree that the zeros are always going to multiply it up will give me zeros. I'm going to put the two zeros here. Line up that 4 with the 9 because I already know that this is going to give me 0 zeros when I multiply that by all those 8s and 9s. I need to focus on multiplying the 4 times the 9, which gives me the 36. 3 goes up here. 8 times 4, 32. 32 plus 3 gives me 35. Now the tricky part here is move decimal over once and twice, plus $356. I'm going to stop and talk about why this makes sense. Let's say it costs $1 to rent each centerpiece, and I rented 400. Well, 4 times 1 gives me 400. 400 and 356 are not that far off. They're only about $44 off. Now, each centerpiece costs 11 cents less than $1, but when you take that over 400, my answer seems very realistic with what my estimate will be. My estimate, because I rounded up, would be 400. Obviously, I rounded up, making my estimate probably larger than my actual answer. 356, I feel comfortable with that. Now we go 49 plus 356. I could slide this right here if I'd like to. We're going to add 9 plus 6, 15. 5 plus 4, 9 plus 1, 10. We get $405. $405. That is a lot of money to spend on centerpieces. I hope they're pretty. All right, let's look at question 8. Brian wrote the prime factorization of 75. Which expression could he have written? Keyword here, boys and girls, prime. Prime, meaning the answers usually have what kind of numbers? Prime numbers. First one, 2 times 5 is 10. 10 times 5 is 50. We want it to be 75. 5 squared, 5 times 5, 25. I would do exponents. 25 times 3. 25 times 3 is 75. It says choose all that apply. Ooh, I forgot to read that. Choose all that apply. That means there's more than one right answer. Have one. 3 to the 5th. 3 to the 5th is the same as 3 times 3 times 3 times 3 times 3. 3 times 3 is 9. 3 times 3 is 9. 9 times 1, 81. I'm done. I'm not going to worry about that other 3. Ignore it. Wait, this one is exactly like this one. It's just they used exponential notation here. Here they did not. But this is the same. This one can be written as 3 times 5 times 5. But they used the exponent. This would be the correct answer. In this one, they add another 3 to it, which would make this larger. This would make this, what, 75 times 3, which is something like, what, 225? I don't know, something. I'm not going to be worried about it because it's already larger. So here's my correct answer. No, 200, what, 75? Now that I'm curious about myself. 75 times 3. Hey, I was right. 15. Yeah, 225. Good. So the correct answer is B and D. Again, using some calculation, being comfortable with adding, subtracting, multiplying, dividing, always key. Question 9. Evaluate the expression 9 minus 7 and 2 thousandths minus P4, P equals 381 thousandths. You know what this reminds me of? Reminds me of back in topic 1, we had to add, subtract, multiply, and divide decimals. I'm going to substitute in this for P. Key thing here, boys and girls, they give us a decimal point. We must line up decimal points when we add or subtract. Put a decimal point here. The number to the right decimal point is 3, 8, and 1. We'll put a 0 here. Let's go ahead now and subtract, because that's the operation to give us, subtraction. 2 minus 1, 1. Cannot take 8 from 0. This becomes 10. This becomes a 6. This reminds me of a calculation quiz we've had. 10 minus 8 is 2. 6 minus 3 is 3. Bring down the decimal point. Do not move it over anywhere. Just bring it down. And that's 9. There's my answer that I enter into the box. All right. Question 10. Oh, boy. A lot of stuff here. I'm going to go now to the online version because this is question 10, and there's a lot of things here, and I want to make sure that I understand what is going on here with question 10 so I know what the drop-down boxes are. It says Zeke has swim club every 2 days and robotics club every 8 days. This month he has swim club on the 2nd day of the month and robotics club on the 8th day of the month. Zeke says that the first time we'll have both clubs on the same day is the 16th day of the month because the LCM of 2 and 8 is 16. Does Zeke's reasoning make sense? Use the drop-down menus to explain. Well, first one's yes or no. Well, let's go back here to the thing. So we have swim club, SC, every 2nd day, and we have robotics club, RC, every 8th day. Now we're going to continually do, so he'll have it on the 2nd day, he'll have it on the 4th day, he'll have it on the 6th day, the 8th day, the 16th day, etc. Robotics club, he'll have it on the 8th day of the month, the 16th day of the month, the 24th day of the month, the 30th. Wait a minute. I am listing the multiples of this, so I'm looking for the least common multiple, not the greatest common factor. Taking a look now. Zeke says the first time we'll have it is on the 16th day of the month. Let's see, 2, 4, 8. Wait a minute. These both have an 8 in them. So, Zeke says, okay, right now, I'm going to have to disagree. I'm going to say no. And let's just make sure that's the option. I forget. No, does not. So this is a no. Zeke found the LCM to the product of, what are my answer choices here? Of 1 and 2, 2 and 4, 1 and 8, 2 and 8. Well, he got an answer of 16. So it looks like Zeke thought that he would multiply 2 times 8. So this would be 2 and 8. But because 8 is a blank of 2, what is the options here? 8 is not a factor. Is 8 a factor of 2? No, 8 is a multiple. 8 is a multiple of 2. 8 is a multiple of 2. The LCM is, let's see what they got here. The LCM is 8. The LCM is 8. So the first day of both is the 8th day. Yes, I feel good about that answer. I have the math underneath to verify it, to justify my answer. Feel good. I'm moving on. Final question. Select the expressions that are equivalent to 15n minus 10. Select the expressions. Wait a minute, that's plural. It means there's more than one right answer. Okay, let's take a look here. We need to combine like terms. We haven't tackled this yet in class. This will be towards the end of the unit. N. This. So we have now, I'm going to write it in the way it has. We have 8 n's. This says minus 3n, so minus 3n. Plus 10n. Let's just focus on these. These are like common families. N. We want to combine the n family. So we have 8n's minus 3n's. That gives us 5n. And then we have plus 10n. Well, that gives us 15n. I like that. Now let's take a look at the next one. We have the integer family, we'll call it. We have 23, 11, and 2. 23, but it says to minus 11, so I'll minus 11. And that says to minus 2, so I'll minus 2. 23 minus 11 gives us 12. 12 minus 2 gives us 10. But wait a minute. Here's my question. Is this a positive 10 or a negative 10? It is a positive 10. So this would really be 15n plus 10. We want 15n minus 10. This would not work. Now, if I recall from last year, I think that Pearson had one of these incorrect. And Mr. Hartwell, Ms. Banjoff, and I also, we contacted each other, we emailed each other, and we did verify that one of these answers they had right was actually wrong. And I want to say it was this question. But let's continue to work on. Okay, we have 20 n's. There's the n family. Any other n family? Ah, yes, 15 n's here. But wait a minute. We have 20 n's plus 15 n's. That gives me 35 n's. We only need 15. That won't work. Hey, distributive property. 3 times 5n gives me 15n. Minus sign, minus sign. 3 times 2 gives us 6. Wait a minute. We need 15n minus 10. Does not work. 5 times 3n gives us 15n minus 5 times 2 is 10. We found a winner. This has 3 to the 5th power. Well, we figure out that 3 to the 5th power is something like 9 times 9, which is 81. 81, that gives me like 200 something. 200, that's not going to work. My guess is that when you're doing the online version, if you get this one wrong, it's because they're counting this one as being right, which it's not. All right? So just a little heads up. If I remember correctly, because this one is what they think is also right. But again, if I look at it, I have 8n plus 23 minus 3n minus 11 plus 10n minus 2. If I combine those common families, I have the n family here, 8n's here, 3n's here with the minus plus 10n. So we have 8n's minus 3n's gives us the 5n plus 10n, that gives us 15n. Now we start with a whole bunch of 23's. We take 11 away from it, which now gives us 12. We take 2 away, which gives us 10. But we still have 10, so that's actually a positive 10. That's why this is not equivalent to this. But again, I think this is, in the system, they have that as being the right answer as one of the options. I completely disagree. I have the math to verify it. All right, hey, hope you have a great time viewing this video. Hopefully it helps you in preparation for the test. Have a great one. See you.